Good afternoon, dear friends. In continuation with our lectures at the CEC Gurukul, today we will be talking about again a very interesting topic on software engineering only, and we will be discussing about software testing. So, in the previous few lectures, we have touched upon different aspects of the process of software engineering, as in we have talked about the requirement specification phase, the validation phase, we have talked about the designing, the coding, we have talked about the cost benefit analysis of software projects and other aspects of software engineering. Today we will be talking about testing per se. So, what is software testing? The lecture will cover various aspects of validation, verification, what is software testing precisely, what are the different aspects and what is the procedure for testing a software, and what are a few tools and techniques which are used for testing of softwares which are made. So, basically when we talk about softwares, so we need to understand that the software can be studied, or the life cycle of the software, it can be studied in the form of a water wheel. We have seen there are different models for studying the life cycle of the software. So, here we will see that in this diagram you can see that the life cycle of the software, it talks about the various phases in the development of the software, like the requirement phase, the design phase, then we talked about the risk analysis, then verification of course, then lies the coding, and after coding comes the testing phase, which we will be talking about today, and then this is followed by various other phases like implementation and finally maintenance. So, this is basically it's called as the water wheel model of software development, and as you can see that the pivotal point of the wheel is documentation, that is documentation is covered in all the phases of software development. So, whatever you are doing, it is important that you come out with a final output document of that particular phase in the software. So, that the documentation is very critical in all phases of the software development life cycle, because it will enable the team to get back to the stage, and it also keeps a record of what were the main milestones covered, what were the problems which were issued, what were the specifications of the user or the client and the customer, and all the other phases. So, therefore, documentation is very important, and when we will be talking about software testing, again we will be discussing various types of documents which are mandatorily required when this kind of testing is done. So, different phases in software testing will come out with different documents, and these documents again they are very critical. These are like logs, and all good software developing organizations, all good software developing companies, they maintain this as a good practice or as a best practice of software testing and debugging. So, we will be if we discuss about a few facts, or if we see the scenario, how is it and how are errors there and how are the faults coming in the softwares. So, we will see that relatively, if you see that there are about 30 to 85 errors which are made per 1000 lines of code, generally speaking on an average, but an extensively tested software, if you look at a software which has been tested a number of times on a number of criteria, on a number of features and on a number of characteristics of the software, then this number comes down to about 0.5 to 3 errors per 1000 lines of code. So, we can very well easily understand that a software which has been thoroughly tested will be a more successful software, and it will help in harnessing, it will help in enhancing the reputation of the company and of the software development team. So, testing is an unavoidable and a very necessary step in case of software development. So, basically testing is generally, it is thought as an activity which is to be postponed or which is to be done only at the end of the completion of the software development life cycle, or maybe after the coding has been done. But it is very important to understand that whenever the code or whenever the error is detected, it is responsible, or the cost, the later an error is detected in the software, the relative cost of removing that error from the software will be high. What I am trying to say here is that if there is an error in understanding the requirement of the user at the initial level, so we can very well understand that if the team has failed to understand a specific requirement of the user, then this particular aspect or this particular mistake by the team is going to percolate down the system in all the following stages. And therefore, if you haven't understood the requirement precisely, then certainly the design is going to be faulty, the implementation of that design is going to be faulty, the effect will show in the coding as well. So therefore, we will say that if the design or if an error is detected in time and if the error is sorted in time, that will save a lot of money as well as effort by the software team, because the error will be rectified right in time. So as it is commonly said that a stitch in time will save 9. So therefore, all errors should be detected. Now there are different studies which have been done on the relative errors which come in and the stages at which the different errors can creep into the software. So we see that about 60% of the errors they occur during the design phase, then 40% occur at the implementation phase, and 66% of these errors they are shown and they are at the design errors, they are not discovered until the software has become operational. So basically a large number of errors are remaining and they remain undetected till the time the software has become operational, it has been implemented completely. So basically if you see this graph, this shows the relative cost of error correction and how the errors are how the cost of removing an error increases with the stage of the software advancing. So for example, in the requirement analysis phase the cost is very less, but if you see the cost of removing an error in the operation phase, so then this cost becomes very high. So therefore the software team should see that the testing phase should not be postponed, it should not be deferred to a stage when the software has become operational, when it is implemented, but at each step of the software development life cycle an extensive testing mechanism should be done, proper documentation of the software should be done. So there are a few good practices which we always say for software testing. One is that you should have a dedicated team of people who are there for only testing the software. Then proper tools, techniques and a systematic procedure is very important. If you are having a random kind of software testing, it means that the testing procedure is not going to give good results. So it has to be a systematic procedure and a scientific scientific method is to be followed for testing the software, and it should not come like randomly or once in a while. Kind of an ad hoc approach for testing of the software should not be used. And also the documentation and the software test plan which is prepared should also be prepared accordingly, and the plan should be followed. So basically it is the software which is under test, it should be completely thoroughly tested by separate teams, as well as we say a regressional testing should also be done, a backward testing should also be done once the complete testing has been done. So basically when we talk about testing, or when we talk about the phenomenon of seeing whether the software has been developed according to the requirements of the user or not, so there are two key terms which are used very commonly. One term is known as software verification and the other term is known as software validation. So verification and validation, both these are intended to show that a system conforms to its specification and meets the requirements of the customer. So basically both these steps, they want to check whether the process is according to what the client wants, and it reviews the process and performs the system testing. So basically validation and verification, they are very closely related terms, but yet nevertheless they are quite different from each other also. So basically system testing involves executing the system with test cases that are derived from the specification of real data to be processed by the system. So whatever is the real data, the system testing will take that data as a scenario, and it will run the system with an objective to find faults in the system, to find errors in the system. So when we are talking about verification and we are talking about validation, so we are basically, when we say verification, we want to know whether we are building the product right. That is, it tests against a simulation. The software should conform to its specifications. So basically we are seeing that whether we are building what the customer or what the client wants. This is called as verification. Whereas validation means that we are building the right product or not. That is, we are testing the software for real data. It is not a simulated data. We are testing it for real world situation, and software should do what the user really requests or requires it to do. So sometimes basically this nuanced difference is because in case of verification, the company must have understood something, but the user wants it to be in some other way. So in validation, basically we are checking what the user actually wants, what is the user's view of the software or of the product that is going to be developed. So basically verification and validation, they go hand in hand, because it ascertains that the product is which is being built is the right product, and also the product is doing what it is supposed to do. So whether you are building the right product, and also you are building it the right way. Both these things are very, very important. So basically verification and validation, they have a similar kind of goals. It's the main goal is to establish confidence among the user in whatever has been developed or whatever has been created is as per user's requirement, and the output that it will be generating will also be as per user's requirement. So basically there are two principal objectives of these two steps, that is verification as well as validation. First is the discovery of defects in the system and the assessment of whether or not the system is useful and usable in an operational situation. So one important thing is that the entire exercise of validating or testing the system is to be done with an objective of finding faults. The main psyche should be that we should not show whether the system is working, but we should show when the system will not work correctly. And also it should be operational in the given environment in which it is supposed to work. So basically this does not mean that the system will be free of defects. Of course there will be defects and the system will always be correct. No, there is a very less possibility that any system which is developed is free from all possible defects. The possibility is there, but the objective is to minimize those defects in the system, so that in the given operational scenario the software will work in like an ideal software, and it will give the least number of errors. So basically it must be good enough for its intended use, and type of use will determine the degree of confidence that is needed. So it will provide the degree of confidence in the user, it will enhance the user's faith in the system. Once these exercises, the validation and verification exercise has been done correctly. So basically it depends on the system's purpose, user expectation and the marketing environment which will determine the user's expectation of the system. So software functioning is basically the level of confidence will depend on how critical the software is to an organization. So if it is a very critical system that is being developed, then extensive verification and validation is required before the system can be handed over for the user to use use it, because if the user's confidence is not met, if the user's expectations are not met with at any point, then the entire purpose of having a software for the critical needs of the user may be defeated. So, user may have low expectation of certain kinds of software, and it is also important to see the marketing environment in which the software is going to be developed. So, getting a product to market early may be more important than finding defects in the program. So, therefore, sometimes because of the situation in the market, the competition, there is another product by the competing company which is going to come up. So, sometimes this, because of these issues which are beyond the control of the testing team or beyond the control of the project development team, there are critical strategic decisions which are taken. So, these decisions may also sometimes affect the way the software has been validated or it has been insufficiently tested by the users. So, basically the verification and validation can be done using two methods or two strategies. One is the static verification and the other will be the dynamic verification. So, in static verification, it is concerned with the analysis of the static system representation to discover problems, and software inspections will be done which may supplement by tool based document and code analysis. So, static analysis is done and then there is a formal verification which is also done. So, basically in static verification you have scenarios which are built, and on these scenarios or on these studs the software is tested, and basically it is the structural design of the software which is tested through these. And in case of dynamic verification, it is more of real time user data which is used, and dynamic verification will actually come under the purview of system testing. So, in this case, in dynamic, it is the operational behavior of the system which is going to be tested rather than some static functioning of the system which is going to be tested. So, basically we are going to observe the product behavior in a given environment, the operational behavior of the product in a given scenario, in a given environment with live with real time user data, and this system is executed by, you have some test data, and then you see how the confidence level of the user is determined once this kind of a system has been tested through this. So, system testing basically will come under the purview of dynamic verification and dynamic validation with users data to ascertain the characteristics of the system. So, basically software testing is defined as the execution of a program with specific test cases to find faults. Each phase may leave some undetected errors, as I already said, and these errors may sum up at the end, and they may become a major fault in the software. So, during testing, errors which are detected from all the previous phases must be detected. So, all phases in the software cycle must have left some undetected errors, like there must have been errors in coding, there must have been errors in understanding the requirements, in designing, in implementation of the design, along with the errors which have come in the recent coding phase. So, during testing, all these errors have to be detected and these must be rectified. So, testing is a very comprehensive exercise in which the errors which have come up in different phases, they will be dealt with, they will be removed from the system. So, basically before we actually start talking about the software testing procedure, we need to understand a few commonly used terms in case of software testing or in case of software errors per se. So, there are three terms which are used very commonly. One is software error, the other is software fault, and the third is software failure. So basically these three terms sometimes they are used in close coherence with each other, and users are not very well aware of what it is. So first term that we talk about is called the software error. So software error basically is any human activity resulting in software containing a fault. So error refers to the difference between the actual output of a software and the correct output. So if the actual output of the software is not as the estimated or as the expected outcome, then there is supposed to be an error in the system. A fault is basically a manifestation of that error. So it is the failure which of the system in performing its required function. So a fault is the basic reason for software malfunction and is synonymous with the commonly used term called the bug or a defect. So any defect will come into the system because there is an error into the system, and there can be errors, there can be faults in the system which go unnoticed also. So so basically it is the error which causes a fault, and a fault which will lead to a failure of the system. So basically a fault may result into a failure. So it is the inability. What is failure? It is the inability of the system to perform, or it is the inability of a system's component to perform a required function according to its specification. So a software failure occurs if the behavior of the software is different from the specified behavior. Failures may be caused by functional or performance factors. So it can be, failure could be due to any reason, and there can also be faults remaining in the system which will not cause any failure. So a system can be running fine with a number of faults still remaining in that. So therefore testing a system becomes even more critical, because there could be a situation in which a fault can manifest into a failure. For instance, if we have designed a system which expects the user to give only a positive number as an input, but the system did not keep in view, or the system did not factor in that the user could give a negative value, or the user could give a text value, or it could give an illegitimate value as an input. So whenever the user will give a negative value into the system instead of a positive value, then this can result to a system fault, which can finally maybe the system may come crashing down, or the program may stop working, or the system can behave anyway in any abnormal way. So basically that is going to be a failure of the system. So therefore when the system testing is done, this is important and this is critical to understand, that the errors should be removed so that they do not manifest or they do not grow up into faults, which will eventually show up as the failures of the system. So another important set of terms which is used is test case, test suite and test harness. So basically a test case is often called as a test, which can be considered as comprising of a set of test inputs and execution conditions which are designed to exercise in a particular manner. So basically we design the test cases which have the input values which are to be provided to the system and certain conditions for execution of those input values, and we expect that when the test case is run, the system will perform in a specific behavior. A test suite is basically a group of related test cases that are generally executed together to test some specific behavior or aspect of the system. So basically a test suite will be a cluster, or it will be a group of test cases which is done for this purpose. And then we have a testing framework, which is also sometimes called as a test harness. It provides an easy means of defining a test suite, executing it and reporting the results. Nowadays we have tools which are automated tools for running the test suite or the test harness. So basically in these automated tools which are available. You can provide the test cases. There is a ready list of test cases which can be provided, and these can be in the form of a test suite which can be provided. You can very well define the environment or the other parameters along with the test cases, and then by the click of a button these test suites will run. So, basically it provides a framework of conditioning, and this also this kind of a growth or technique has always has changed the way testing has been carried out. It also defines the way in which the results for testing or validation has been done. So, basically now we will be talking about the different levels of testing, because what the testing can be performed at several levels, like we have the unit testing, the integration testing, we have validation testing. In validation testing we talk about the regression testing, the alpha testing, beta testing, and finally we have the acceptance testing. So, each level of testing is basically related to a specific phase in the software life cycle. So, each level will determine which phase errors from which phase of the software are going to be tested in that particular environment. So, if you see this diagram, this explains the different testing levels which are tied up or which are related to specific phases in case of software life cycle. So, first initially are the client needs. So, client needs are met or not met. This is tested at the acceptance level testing. If the requirements of the if the system maintains the requirements of the client, is tested as a part of the system testing phase. The design of the system has been according to the functioning of the system or according to the environment or operational environment of the system is done using integration testing. And then we have the code, whether the code has been written correctly or not is done as a part of unit testing. So, we can see that different levels of testing are performed to check the confirmation of the system to the user's need and that the system fulfills the user expectation in all circumstances. So, basically when we talk about unit testing, so we are talking about the software, the code or the programs which are written using a programming language, whether they meet the requisite specifications or not. So, in this case the first thing that is checked is whether the algorithm or the logic which the programmer has used is the best algorithm and logic possible or not. The algorithm should be the most efficient algorithm which uses the minimum system resources and the minimum time. So, the most efficient algorithm should be utilized for performing any activity or writing any code for the program. Then of course, the data structures are to be checked by the testing team, whether they are coherent, they are consistent use of data structures has been done, so as to increase the efficiency of the overall system. The interfaces, the user interfaces, the interface among the different modules is to be ascertained, so as to estimate how the system will communicate with the user and among the different components of the system itself. Then several independent paths, boundary conditions, certain exceptional conditions are to be checked, exception handling, how the software or how the code is going to handle if in case an invalid input is provided to the user or in case the system behaves in a non-routine manner. So, all these exception handling, boundary behaviors, error handling situations, which how the system neatly handles each of these, how the code has neatly been written, how it has been documented well or not, all these things are tested as a part of unit testing. Then we have integration testing. So, once the code has been written, now generally we have structured programming approach which is used, or we have different teams working on different modules. So, when different modules have been developed by different teams, it is very important to have an integration testing done, so as to see whether the different components or the different modules they work perfectly fine when they become integrated into a single system. So, one module can have an adverse effect on another module in this case, and sub-functions when they are combined, they may not produce the desired major function. So, individual acceptability imprecision in calculation may be magnified to unacceptable levels in this case. So, therefore, integration testing becomes very important. Interfaces errors are not detected in unit testing because you do not know how the system will behave when each of these components is going to test, because till now individual components have been tested, but the way these components are going to interact with each other and how the result is going to be given. Also, the race conditions or how the system resources will be utilized when the module is integrated into one large module is also important. Timing problems are also to be ascertained. So, therefore, because of all these things, integration testing becomes very important in real life system, because they are all these situations, they cannot be detected, they cannot be efficiently managed, the faults cannot be captured in case by the unit testing. So, basically integration testing, two approaches are used for integration testing. One is the top down approach for integration testing and the other is the bottom up approach for integration testing. Now, if we talk about the top down approach for integration testing, in the top down approach, what is done is that the main module or the driver module is written first, is tested first, and then the sub modules which the main module is going to call, these are going to they are integrated in one phase, and after the integration of each sub module or each stud as we call it, so after that the testing is done again. So, basically it is an incremental testing which is done after each module, each sub module is added to the system, then the interfaces and how the function subroutine is being called by the major module and how these module and how the system comprehensively will work is done in case of top down approach. In case of bottom up approach, you begin from the smallest unit and you incrementally build the subsystem, and hence each of these sub modules which are added, they form a cluster, and then further these clusters built up, and finally you come to reach the sub module, the main driver module. But the problem with the bottom up approach is that you cannot test the complete system until the end of the integration has taken place, whereas in case of top down approach, this problem is mitigated because initially you begin with the driver module. So, basically both these approaches, they have their pros and cons, and depending on the architecture of the system and depending on the features of the system which is being developed, the operation is the testing approach is utilized. So, basically when we talk about the other type of testing which we have discussed is the validation testing. So, if we determine that the software meets all the requirements defined in the software requirement specification, this is done by validation. So, having written requirements for this phase is essential because that will serve as an input for the software validation phase. So, basically this will tell that what the system which has been built is the correct system what the user wants to get it. The next type of testing is the regression testing. So, regression means that in case we already have a system in place, we have a system which is working and we want to check this working system. So, we go back in time and then we check this system. So, it is basically performed to determine if the software still meets all of its requirements in the light of changes and modifications to the software. So, certain modifications are made to the existing software and then it is then it is put up for regression analysis or regression testing, which involves selectively repeating the existing validation tests and not developing new tests, because this system has already been running and there are only minor modifications which have been made, minor or maybe major modifications which have been made. So, therefore, the test cases are designed in such a way so as to check the new modifications and how the new modifications have been integrated with it. So, regression testing is basically performed for a system, for a pre-existing system, and only to check for the new changes which are available in the new system. Then of course, we have the alpha and the beta testing. So, it is best to provide the customers with an outline of the things that you would like them to focus on, and specific test scenarios are to be designed for the customers to execute. So, basically the customers who are actively involved with a commitment to fix defects that they discover. So, customer participation is very important in case of software testing, because the user sometimes knows the best ways in which error can occur, or in which the real world real time scenarios they understand the domain in which the software is going to function, and therefore the testing process cannot be completed without an active participation of the users. Then of course, we have acceptance testing. So, acceptance testing and validation testing are basically very similar to each other, because in this case, in acceptance testing, the customers are directly involved, they are physically present while the software is tested. So, usually this test is developed by the customer only to see how the software can be assimilated into the existing system, into the existing procedures of the company, and how the general user of the software can utilize it. So, basically acceptance testing is to do more with the customer participation and the customer's approval and the customer's acceptance of the fact that they will shift to a new system of work culture. Then so different levels of testing have been discussed, like we have seen how the software units are tested, then you check about the integration, then there are different testing methodologies which we use or which we employ for the client level. But basically, if you have a testing process in place, then the main problems or the main issues which the testing team may feel they may be rectified to a great extent. So, testing process is it basically consists of 3 high level tasks for any project. The first is test planning, the second is test case design, and the third is test execution. So, this is a systematic process which needs to be followed, and once this test planning has been done, a test plan is a document which will be available for the testing team, and this plan will chart out the different test cases which are to be built, the timeline, the schedule, the resources, the manpower which will go into the testing, and it will also help the testing team in documentation. So, testing is a very important exercise, because the success and failure of a testing exercise will directly affect the quality of the software which is being released. So, basically when we talk about test planning, so a test plan is a general document for the entire project that defines the scope, approach to be taken, and the schedule of testing, as well as identifies the test items for testing and the personnel responsible for the different activities of testing. So, the test plan is a very comprehensive document which will talk about the what's, the hows and the whens of the testing activities which are going to take place as a part of a software plan. So, basically a test plan will define the scope of the work to be performed by the testing team. It will define the test procedure, that is again test procedure will also be a document which will hold off all the individual tests, that is the scripts which are to be executed. It is a comprehensive list of all the test cases which need to be tested, and then a test report. So, this test report documents what occurred when the test scripts were run. So, basically it will keep a tab or it will keep a log of all the test scripts and the results or the outcome of the running of the particular test script. So, basically a test plan should contain information about the following things. First is the test unit specification, the features to be tested, the approach for testing, the test deliverables, and the schedule and task allocation. So basically the test unit specification is important because the unit should be defined and it should be testable. What unit of the program or what unit of the software is going to be tested is important, because the unit which is chosen to be tested should be a critical unit, but at the same time it should have the attribute of being tested and should be the test should give a concrete result for comparison. So it should be a more logical unit of software testing, which can also show the interfaces and the integration with other units. Then each software has some specific features or characteristics against which it is to be tested. So depending on the nature of the software, like it could be response time of the software which is more critical, or it could be reliability of the software, or it could be fault tolerance of the software. So exactly which features or which characteristics are most critical for the user is important for the software plan to define. Then different approaches for testing can be suggested, or different approaches or different tools can be used. So what tools or what approach for software testing will be used, and finally what will be the deliverables after the test has been done, what will be the output, in what form the reports are to be given, in what form the documentation of the testing has to be done, and then the schedule of testing, as in how and when, how often, what is the frequency of the testing and activities to be done, and what are the resources, the persons, the people who are going to perform the activity, how are these going to be allocated. So a resource allocation plan is also a very important element of the test plan which is going to be used. So basically it will answer a lot of questions, that is, what are the tests which are required, how long will it take to develop those tests, how long will it take to execute the tests which have been defined, and other topics will also be addressed in this, like test estimation, development and informal validation, validation readiness review, formal validation, and test completion criteria. So when will we consider that a particular test has been completed? So test estimation basically will talk about number of tests required, and this is based on testing all functions and features in the software requirement specification document. So it includes an appropriate number of act like a customer tests, which tests include do it wrong, that is, if a customer gives a wrong input or does nothing at all, or doesn't do anything, or does too much, or gives a wrong or illegal combination of inputs. So basically we are trying to cover as many scenarios as possible for estimation of the error. So we are trying to behave like a customer, and we are trying to see all permutation combinations of how a customer can give any different input, or how a customer can interact with the system so that the system may not give any error. So basically it is the reliability goal which one will estimate, which one will achieve actually by the process of this software testing. So basically when we talk about test estimation, it is very important to talk about the complexity of the test. So it is better to have many small tests than a few large ones. Then different platforms must be used, so different parameters should be modified, and operating systems and the portability of the software on different operating systems, on different hardware and software platform, how easily it can be ported on different platform, and how well it can work on different platforms is also an important consideration when test cases are being defined and when test estimation is being done. Then we can also think about an approach of automated or manual testing. So automated tests can also be developed, as I already said that these take more time, but then they do not require any human intervention to run. You already define a test case suite, and you provide the environment, and you provide the framework like an harness, you provide the test harness, and then automatically these tests can be run. So these tests, they will give they although will take more more time in initial phase, but then the results that you get are far more quicker. So, basically when we follow a procedure, the test plan has been prepared and it defines a test procedure to be followed. So, when the testing procedure means that there is a collection of test scripts, an integral part of each test script is the expected result. So, you know that if you are going to provide this input, what should the system give as output. The test procedure document should contain an unexecuted clean copy of every test, so that the tests may be more easily reused. So, again the test, this can also be an iterative exercise, because if a fault is detected, then again you go back, and after the fault has been fixed, after the defect has been fixed, again the testing is to be done. So, basically it is important to understand that for testing there is a specific psychology which we need to follow. The testing team needs to have a specific mindset before they go for a testing procedure, because their goal should not be to see whether the software is working, but their goal should be to see that the software is not working. Only when they have a goal of seeing or finding errors or faults in the software will they be able to find it, because the conditions or the test scripts or the case scenarios, they will only be then designed so as to challenge the system. Otherwise, if the goal is not that of testing the system, or rather it is of proving that the system is working correctly, then a successful testing exercise cannot be accomplished. So, then finally after the procedure has been run, the test scripts have been run, a comprehensive test report is prepared, which is a completed copy of each test script with evidence that it was executed, or dated, and signature of the person, and a complete evidence that yes, the script has been run, and each copy of each software problem report showing the resolution is there, and list of all open and unresolved software problem reports is also kept along with it. So, whatever problems were reported in the software, they are all made a part of the software test report. Identification of software problem reports, which is found in each baseline, along with total number of software problem reports in each baseline, is done, and regression tests are executed for each software baseline. So, basically it is important to see what are the problems which came in, and also to see whether those problems have been fixed by the team, by the concerned people or not. So, in case the next step after the software plan and the procedure is the test case design. Now, this is a very important exercise to determine what are the right kind of tests to be performed to ascertain whether the software is a successful software or it is there are a lot of bugs in it. So, basically it is to be done separately for each unit, because you need to check each unit individually. So, test case specification gives for each unit to be tested all test cases, inputs to be used in the test cases, conditions being tested by the test cases, and outputs expected by the user. So, basically generally this test case design is given in the tabular format, in which you have the requirement of the user, then the test case definition, or what test case will be performed to check whether the requirement has been fulfilled or not, and what is the expected outcome, and what is the input variable, or what is the input which is being given to the user for that purpose. So, effectiveness of testing depends very heavily on the exact nature of the test cases, and the effectiveness of the test cases will ultimately determine the quality or the level of the software product at the end. So, once the test cases have been designed, they have been defined, the correct input, expected output, and the environment or other conditions have been defined. The next is execution of those test cases. So, test case specifications only specify the set of test cases for the unit to be tested. However, executing the test cases may require construction of driver modules or stubs. So, basically we have already discussed how in an integration testing the modules are defined. So, it may also require modules to set up the environment as stated in the test plan. So, we have already prepared a test plan, and in that case we create this test case execution according to the environment variables which have been defined. So, today this shall be all for today, and we will be continuing on specific tools and testing methodologies which are used and approaches to testing in the forthcoming lectures. Till then, thank you.